Welcome to this new video. In this video, we will learn about Outbox Pattern. Outbox Pattern is very much important when you are designing your event-driven systems. So before jumping into Outbox Pattern, we need to understand what issue is getting resolved by Outbox Pattern. Okay. So for example, let's say you have account service where you are updating your account balance and then you are pushing that event to your notification service, which will first get sent to the message queue, and then message queue sends it to your notification server, and the notification server is sending the actual notification. So everything is works fine, but no, here is a catch. What if your update account balance uh, works totally fine and then your server crashes, so you are not able to push the event to your message queue? We cannot tolerate this, right? And it's not even like a database transaction, so we need some kind of a rollback thing. So if one of the processes like one of the processes failed, then everything will be rolled back to its previous state. So how can we ensure that? To resolve this, we need to ensure that instead of pushing this event notification, we somehow need to put it inside a DB operation, so we can put all of these two things into one transaction, and we know that if in transaction one of the thing gets failed, then everything will be rolled back. So here comes our outbox table. So you have the same account service. Now you are doing a transaction. So what you are doing, you are updating your accounts, and right now I'm just deducting the balance. And then what I'm doing, I am having an outbox table which will store the events, the event, the details of the event, like event type, the payload. Payload will store the actual message, and the status. Status will be like if we are creating it for the first time, then we will pass it to the pending state. Then we will commit it. So we are ensuring that in a transaction, if both of the steps happen, then everything is fine. If one of them gets failed, then nothing will happen and everything will be rolled back to its previous state. So now we are good to go. And our outbox table will have list of events that are in pending state. Then we need a relay service or a polling service, you can say, which will pull the data from our outbox table, which will periodically check which of the rows have the events like in pending state. Those will be fetched out from the table and then pass it to the message queue, and then we will ensure that okay, so we are good to go. And now we will have to update that outbox. um, we have to update this outbox row to like status to done, because we are done, so this task won't get picked up on the next time our server polls the data, and then message queue will send the notification. So here we are ensuring that uh, we are we are ensuring that what are the problems. So here we can see that the problems that we were facing previously, that's not going to happen in this case. Also there is another issue. Let's suppose your polling service sends the event into your message queue, and then it needs to like acknowledge the table. It needs to update the table status, row status to done, in order to tell the outbox table, so this event has been processed. So if it fails to update this, it can happen that our message queue picks the same row again and again and processes it, right, and pushes it to the notification server. So in order to fix this, we need a deduplication ID, which will be passed alongside with the message while processing it with the message queue. We have to store it inside our outbox table. It has to be a unique ID, which will ensure that okay, this ID has been already sent to the notification server. We do not need to send it again. So deduplication ID will be enough to fix this issue. And here we can see that we are polling this data. Well, our service can get overwhelmed by polling the data, so we can also design this in a push based system. Like we can use a CDC, which will see what are the changes that has been done into our database, and then it will stream all of the changes to our services. it will pushes it. Like we can use Debezium, Kafka for this change data capture, and we can put our change data capture into our Postgres service or any other DB services. There are lots of CDC out there, so we can either use polling the data, or for pushing we have this things based on our use case and our need, our requirement. We need to think about what architecture we are going to choose. So that's all for the video. I hope you have learned something new. Share them with your friends. Keep learning, keep grinding. Bye.